We're recording. Okay. So let's get started. All right, guys. So today we're going to continue our discussion. Today's Thursday. We didn't have a class on Tuesday because of the holiday. So no lecture this week, right? Next Tuesday, we'll continue with the RSA lecture, basically. Today in lab, we're just going to look at something, a new thing that we're going to be using in the coming weeks. So the topic this today is going to be PyCryptoDome. So, we've pretty much gone over all the algorithms. Um, and we're still going to look at some algorithms, like blockchain and things like that, how that works. Although we're not really looking at algorithms anymore, I would say we're looking more at frameworks, right? So it's like we started with primitives, we looked at the algorithms, right? And then we've started to use the algorithms as objects and combining them. We need to discuss SSL, right? SSL, secure socket layer, and how that works. And also, we're going to start building more complex things, digital signatures, and things like that. So that's kind of what's coming up. So I'm going to introduce today the PyCryptoDome library. So this is what's used in the book, for instance, the Seed Labs book. And it's a very powerful library that, it's nice. It's very object oriented. So not really about the algorithm anymore, but just using like the object, the function, etc. Right. So we're going to do that. Pay a lot of attention to all these scripts because, as I said in the practical exam, I kind of use all of them, right? I'll use the RSA one that's the homework due tonight, I believe, right? So we'll be using that, and then I will also use the PyCryptoDome heavily, right? And I think you'll like PyCryptoDome because it brings in everything. So we'll be able to do symmetric encryption, we'll be able to do hash integrity, we'll be able to do authentication, RSA, digital signatures, and so on. All right, so it's as I said, a nice library. So I'll go over this today. I'll start. I don't know if we'll finish. We'll see if I give you a homework assignment. Because I don't know if I'll finish the topic, but so you guys are seeing there 350. You can go to content. And, and like I said, since I haven't finished like the RSA background math and some of that, I don't really want to move on that yet. So this is a good thing to do, kind of standalone in itself. So you can see PyCryptoDome. It used to be called PyCrypto, and then it evolved. Like version 2 is PyCryptoDome, and it's pretty solid. All right, so we'll be looking at this. Basically, PyCryptoDome, this link just takes you to like the website for PyCryptoDome. You can read through it if you want to become an expert in PyCryptoDome, right? So beyond this, what I'll do, I'll just provide some examples of how to do this. I do have one problem here as homework. I'm still deciding when I'm going to assign this, but yeah. But today, just should be fun day. Just go over all these scripts. So basically, you can see here, no, sorry, PyCryptoDome. So all the scripts that I'm going to be discussing today are here in this link. You can, on the GitHub. So we're going to do all of these. So I kind of have like a whole bunch of little scripts. And as you can see, the names imply what they do. So we got AES, encrypt, decrypt, generate RSA, RSA, encrypt, decrypt, signatures, integrity, and so on. Okay. And so this is what we're going to take a look at today. And we're just going to play with PyCryptoDome. I'm pretty sure a couple of weeks ago, we installed PyCryptoDome or we tested it somehow. So we should all have it available in our computers. Okay. Any questions about anything, guys? So the homework is due tonight, correct? Yeah. Any questions? Oh, good. I finished grading your exams. So I think I'm caught up there. Might be behind one or two homework assignments, but should be good. All right, so let's go ahead and start the virtual machine then. We'll go over that. And as I said, you'll be able to encrypt and decrypt things with PyCryptoDome more effectively. Okay, so let's go ahead and start the virtual machine. And, we can start with easy things. So we'll probably begin with integrity, for instance. Let's do that. Then let's go through symmetric encryption, block ciphers. Again, just with this library. So no more of the, for loop and all that. And then we'll finish out, obviously, with RSA, for the key exchange and various other things. So we'll build up some scripts. So the first one I'll go over is integrity. So just to kind of illustrate some of the concepts of how this would work, we'll just give the computer a minute. We're currently on week 8, right? So the next exam would be week 12. Remember, the practical exam will be around week 12. Okay, very soon also we'll start talking about term project. What you should start thinking about a term project, probably groups of 2 or 3, and then it'll be something, doesn't have to be coding, can be just some application. Just explain an algorithm or something like that, but make sure you implement a demo, basically. But it's not worth that much. It's only 10% of your grade. So I'm not looking for much. Obviously, breaking, cryptography, things like that are always fun to do. Okay. All right, so let's give this a minute. All right, so here's the virtual machine. So let's open up the terminal. Okay, let's start. All right, let's navigate to ITS 350 fall 2024. Where? I'm gonna call this one PyCryptoDome. There's a lot of scripts. Um, Keep in mind, one of these homework assignments also, besides the practical exam, one of the homeworks you'll have to demo with your partner. Okay, so that's also, and it's going to be, that one is based on PyCryptoDome. That's me just making sure that you guys understand, like everything. Okay, so definitely pay attention to this one. All right, dash L, PyCryptoDome. All right, so perfect. So let's start. I'm going to create, I'm just going to call it integrity.py. Okay. Um, so the library is crypto. I believe we had installed this. We had done something like pip install PyCrypto or PyCryptoDome. Yeah. So I'm pretty sure we've done that already. So you should all have it. So from crypto, and then this library has everything that you need, right? So it'll have RSA things, it'll have MD5 objects, AES, right? So, just like OpenSSL, but now all written in Python. One semester, some students built like a ransomware tool, right? All in Python. So you can totally do that with something like this because it's just a script. All right. So let's go ahead and do hash. And from hash, I'm going to keep in mind this is case sensitive, so be careful with the uppercase C and H and everything. So I'm going to import MD5. Okay, as you know, it's a hashing algorithm. So I'm just going to do that just to make sure I have my library set up. PyCryptoDome. So I'm going to do Python You guys use Python 3. All right, so no errors. So that tells me that the library is available. All of you who run this script should get this. Okay. Yeah. All right, great. So now we're ready. If you got this, then we're good to go. And now we can start very simply, we can start using all these tools. So this is kind of where, where I start to like, I've talked about RSA one time, or I talked about block ciphers, ECB, whatever, right? We've talked about all those things kind of in a separate way with OpenSSL. Everything was always kind of standalone, right? PyCryptoDome is really nice, and I like to use this to kind of bring everything together now, right? So I can, create 3 libraries here, right? And I can do from crypto hash, from crypto RSA, from crypto AES, and boom, I have all 3 items in there, and I can start taking all these primitives and building new things, okay? And so that's kind of the nice thing about it. So we're going to use everything that we've used so far in the semester, like Pickle, we can use that to save our keys and everything. All right, so yeah. So let's go ahead and just do an integrity one, kind of to get started. So everything is object oriented. So that means we need to instantiate objects. So here, MD5 dot new, right? So that creates a MD5 object. And then I'm just going to give it something to hash. So I'm going to say string value. Okay, so I'm going to do something like buy the stock at 2,500 a share. Okay. So that's, basically I have a sentence here, and I'm going to hash this. So I'm going to do m.update, and then I'm going to take string value as my input, right? String value. And then that's basically now I can print the hash in various ways. So I can do m.digest, right? That's the hash value. And just you should add parentheses probably. Let's see. And then also we're going to print it as a hexadecimal. So I'm going to do m hash value. And I'm going to take m dot hex digest, like that. And then I'm going to print that one. Print m hash value. All right, let's go ahead and run this. Let's see if we get any errors or anything like that. But our goal is obviously to create the hash value, right? Remember, all these scripts are in the GitHub, so you can get them from there. All right, I'm going to do clear here. And please raise your hand if you have any questions or anything like that. And we get an error. Great. What is the error? Let's see code. It gave me an error in the update, I think. Yeah, yeah. So the loveliness of Python. All right. So yeah, so it wants it to be it's telling it to treat it as a byte array. It's like a typecasting kind of a trick. So you'll see this. This is a common error. So if you put this in there, basically, so remember that this is PyCryptoDome. PyCryptoDome is a library built by software engineers, right? People, researchers in cryptography, and they've built it in some specific ways, and they just want things to be in a certain way. So this just converts the string into a byte array. It was complaining that it didn't like a string as an input to so we might have this error going forward. All right. But anyway, let's go ahead and, so I didn't do any changes. So run the script. You can see basically we've got our hex value here. This is the hex digest that I would use probably to exchange, uh, you know, and then basically we know the concept of integrity, right? This file, if we receive it and we run this MD5 algorithm, it should give us the same hash. It basically means that it wasn't changed, and that's integrity. All right, so let's kind of do now like how you would implement this in your code, right? So I'm gonna create a new MD5 object just to kind of show you. I'm gonna add a line of code here. This one's gonna be, the previous one was M, this is gonna be N. And I'm just gonna do N, again, MD5. Dot new. Okay. So that instantiates the object, and this gives you the same idea. Now I'm going to have a new string, right? And I'm going to call it spoofed string value. Okay. So this one is going, I'm going to need that B in there. So this one is going to be buy the stock at 4,500 a share. Okay. So basically here, I'm changing one bit. We want to make sure that the message has not been changed, right? So in this case, this should give us a totally different hash value. So I'm going to go ahead and try it out. N dot update. Oh, sorry. Yeah. Oh, yep. Sorry. Thank you. Thank you. All right. Yeah. So we're just going to calculate the hash value for this one as well. So we're going to do spoofed underscore string value. Okay. And now we just calculate the hash basically. So in this one, N hash value. And this is going to be N dot hex digest. Okay. So N hash value, N dot hex digest. Okay. So we're going to print this one out. So print N hash value. Right? Similar. Everyone with me? So we've got two. I'm going to run them. And we got two different ones. So you can see now with Python, with these libraries, we can start to build. The whole point here is that you can start to build applications, start to build things, right? When we do, for instance, we'll do several applications like malware, denial of service attack, which crypto, what I mean is we can use crypto to prevent denial of service attacks, to detect malware, obviously in HTTPS for websites. And we're also going to see blockchain and Bitcoin, right? Those same concepts. So we'll use Python actually to kind of build those things out. So the great thing about, having these libraries is you can build now applications, basically solutions that use cryptography for something. And you can use cryptography for lots of things, basically, right? As we will see in the coming weeks. Also, I was going to say, before I forget, there's like a documentary that came out on HBO. It's called Electronic Money, I think, something like that. And it's about Bitcoin. So might be something you might want to look at if you have time, it's one of the topics that we will discuss later. It talks about the history of it, but it might like motivate some ideas. I haven't seen it yet, but might be pretty good. Yeah.
Could you go back to Python?
Yeah, sure. All right. So I haven't finished here. I still want to do something. So while you're looking at this code, I'm just going to add the last part, which is basically, you would have some kind of an if statement to compare both hash values and just return true or false if they match, right? So let's do that. So for instance, we can do if m underscore hash value equal n hash value, then 1, 2, 3, 4, we're going to print true, else 1, 2, 3, 4, print false. Okay, so a lot of these sometimes will work like this, when we do the digital signatures, at the end of the day, all you have is you're looking at some hashes, you're checking that they can be decrypted to the same value, and then so really the answer is just true or false, okay? So in this case, hopefully this should give us false. So let's go ahead and run it. False, right? So they're false, right? Because it was changed. Now I'm gonna change, go back and make this spoof string be equal to 2500. So they should be exactly the same. True. So you can see, and this is how we can start to automate. So very simple, very obvious, but we can start to build applications on top of cryptography. Does that make sense, guys? All right, great. Any questions before we move on to the next script? Yes, sir.
I'm still getting an error.
You're getting an error?
Yeah. Does
I'm listening.
for if m has value equals n has value, it says like the equal sign is invalid.
Do you have two equal signs in there?
If that no,
Here you should have two. In Python, you need to use two, otherwise it thinks it's an assignment statement. Did it correct your?
okay.
Got it?
Yeah.
Good. All right, perfect. All right, so this was your very first script, something to do with integrity, right? So I'm not hearing any questions. We're going to move on to another script. And, so so this one was pretty easy probably, but I wanted to start with this one. I'm going to do ls-l. Let's take a look at something else. Let's see. So we've got AES, encrypt and decrypt, and there's several versions of it. There's things for reading in our RSA keys. Remember, you should start to understand at this point that you're going to have how each of you needs to have a public and a private key, right? And then you're going to use that to exchange the AES secret key. Okay. So, and then there's, so let's see, we got des. Let me take a look at this one. All right, let's try this des one. I have des.py. So you know what des is, right? So the data encryption standard, not as secure, but we do have an AES one as well that we'll try in a second. Obviously with des, what we're gonna do is we're gonna try to achieve confidentiality, right? So let's go ahead and create that script. I'm gonna call this one des.py. Yep. All right, I'm gonna from crypto dot cipher. So notice that this has changed to ciphers. Okay, import des. Okay, pay attention to these little details. On the practical exam, I could hide things using AES or des. So you need to like really know and the mode of operation also that I'm using. All right, so let's go ahead and just try the library. Sometimes these libraries change. And so I want to make sure. Oh, yeah, I don't have that. This is des py. All right, no errors. So that means that the library works. Okay, so now I'm going to instantiate a des object. I'm going to give it a secret key. Okay, and I'm going to give it a mode of operation. So let's try that. You should understand all these concepts because we've already discussed them at length in the algorithms at the beginning of the semester. So I'm just going to create an object and give it any name that you want. And then we invoke the des module new, right? And then I'm going to give it a secret key, A, B, C, D, E, F, G, H. Notice that in this case, there are 8 letters. Again, this was implemented by someone, so they made specific decisions about how they want things, right? So some things they may want to be multiples of 8, for instance. So keep that in mind. If something is not a multiple of 8, it may be up to you to pad it, right? To do padding. So, but you guys understand that concept as well. All right, so the key, this thing here, I'm just going to give you a hint on the practical exam. This may be the thing that I don't provide. You will need this to decrypt, right? So it's a key, it's a secret key. So it's very likely that what I will do is I will take that secret key and encrypt it with RSA, right? Because that's what should be done. So I may provide the encrypted version of that key. So how are you going to obtain it? Well, if you had the private key, you could, but it's possible that I won't give you the private key. So then what's the only solution? You have to crack RSA, right? So you need to know how to break RSA, and that's also something that we will cover later. Does that make sense, guys? All right. So I may change the problem, but it'll be similar um, ideas. Okay, so then this should have modes of operation. So I think the should be des dot mode and then ECB, for instance. And you guys should know what that one is. So let's see if this works. I'm going to control X, Y. Okay, so I think I'm missing a comma there. Let's add comma. Okay, all right, let's try it again. Whoops, here. Nope. There. All right. Nope. There. All right. Oh, okay. Doesn't like it's the same error we had before. I don't remember this needing to be an array, but let me try that. Okay. All right. So yeah. So let's see if this gives us an issue. I don't. Let me look at the AES ones actually. AES encrypt. Um, Yeah, yeah. All right. Yeah. So it does need to be. So the whole library kind of likes everything to be already typecasted from a string to a byte array. Just put the little b in front of it and then shoot. Any questions, guys? All right, great. So let's go ahead. All right. So we have our object. You can call it object des if you want, something like that. Des. I usually do with object-oriented things, des underscore obj, and I know that's the object. All right, so now let's go to, obviously, it's probably not a good idea to just do A, B, C, D, E, F, G. That's not a secure key in theory, right? In theory, it's not secure. So what we will do in a sec is to use urandom or something like that and create our keys. And then obviously the problem with that is you're going to have to save that into a file or something. But we know how to do that with Pickle, for instance. So we'll try that. All right, so now that I have this, I'm going to try to encrypt a message with des. And remember, this is for confidentiality. So I'm going to say something like plain. And, so today is Tuesday, what is it? October 10th, comma, 2024. Okay? So we're going to try that message. This will probably need the B to convert it into a byte array, but let's leave it like that for now. One thing that we might want to try is to print the length of this just in case padding is needed. So I said the library is not exactly perfect. All right. And then might as well try to encrypt it. So I'm going to do cipher and I'm going to invoke obj dot and then encrypt. So usually the functions are encrypt and decrypt. And then here, I'm just going to give it plain, right? So this will probably error out for various reasons, but let's take a look. Yeah, so I didn't like, again, our common. So if you get this error, just memorize it in your head because you'll see it all the time, right? The string thing, it just wants things to be a byte array. Okay, so I didn't look at the length though. 33. Do you see that? 33, I guess, is the number of letters we have in there. So that's important. 33, that seems like a lot. Anyway, let's see. So let's put a B in. Oh, no, no. Let's put a B in front of this. Okay. Control X1. Clear. Yeah, there we go. So now it's a different error. Data must be aligned to block boundary in ECB mode. That tells you right there there's some kind of issue with the block size, right? So it's a padding kind of a deal. So 8 times 8, 16, 32. That one was 33, I guess. So what's the next one? 32, 8, 40, right? So 33, so 7. So we need to provide 7 additional letters. Let's try that. So you can, make this as complex as you want. I'm going to keep it pretty simple. We're just going to do it hard coded. So I'm just going to say plain is a string plus probably is like that. And I'm going to say 1, 2, 3, 4, 5, 6, 7. Let's just see if that's enough padding for this to work. Hit clear. All right. Did it work? Yeah. So I'm not printing the cipher. No errors, right? So now we can, the next step is we can try to print the cipher. So I'll let you guys take a look. Raise your hand if you have any questions or if you're stuck somewhere. Okay. So now I'm going to do print cipher just so that we can take a look at our encrypted object. Okay. So let's run it. Right, there it is. So this is the that's the cipher basically. Obviously, we would need to, that you with just that you can encrypt some message, right? And now you just need to save it to a file maybe, and this is what you would email to your classmate, for instance. Okay. Let's now obviously we want to decrypt it. I'm not going to save it to a file right now, but we can do that in a little bit. So I'm just going to add here like a new line. So line, just to kind of separate. Now I'm going to invoke uh, the object again for decryption. So I'm going to say decrypted plain. And basically you just have to call obj dot decrypt, right? And then we're going to give it cipher and we're going to print decrypted Fine. And let's see, that this should give us the original message. So let's go ahead. There it is. Today is Tuesday, October the 10th, 2024. And notice that it's got the padding there, which, you guys from previous examples, previous scripts that we've written, you should be able to remove that. Yeah. Any questions? Pretty easy, right? So very easy. Now, let's move on to AES. So I'll give you the AES algorithm. So let's start with encrypt, obviously. Okay. So I have two examples of AES. So the best thing to do is just to kind of look at them. So I'll start with the first one. So AES encrypt, and then I'll do an AES encrypt 2. So this library has special modules and the special functions. So one of the functions of the AES module that I will use is a function called encrypt and digest. So what that means is that it can generate um, the ciphertext, but also a tag, like a hash value, two things. Okay. And they're basically like one after the other. So you just have to know, like, okay, the first, let's say 16 bytes is this, and the rest is the other part. Okay. But let's take a look at this example. So I'm going to do clear ls-l. I'm going to create a new script here, nano AES underscore encrypt dot py. All right. So now we're going to invoke from crypto dot cipher. From there, we're going to import AES. The advanced encryption standard. So we've talked about it in the lectures, right? And we know this is more robust. So we'll be using that one. I'm also going to, just like before, you invoke random, and then from this is a specific random module in PyCryptoDome, and this is so that we can generate keys randomly, right? So I'm going to use a function called get random bytes. So this is something else. So I'm going to do from crypto dot random. I'm going to do import get random bytes. Okay. So now the first thing, let's just have some data in here. I'm going to use the same example as before. So I'm going to say, the B, of course. And then today is Thursday, October 10th, 2024, right? So 2024, right? That'll be our message. And now I'm also going to have a secret key. So remember that the secret key is the name given to the key that we use with AES and DES. So in this case, secret key, but this time around, it's going to be a random sequence of bytes, and all we have to do is specify the size. So I'm going to use the function get random bytes of size 16, just like that. Okay. So now I should have my secret key. So let's just run those. I'm going to do Python 3. Okay, no errors. Very good. So now we can proceed to um, instantiate the AES object. So I'm just going to say in this case, cipher AES. So I'm going to invoke the library, the module AES. So it should be an assignment statement here. AES, and then now dot new. This will take, now this is a sequence of bytes, so it's already formatted properly. So this is secret key, comma, and then now we have different modes of operation. So there's actually a mode of operation called AX. So that we're going to be using here. So mode underscore EAX, basically. Okay. And now that we have the object, I'm going to proceed to create the cipher, but also it's going to generate a tag. So we'll take a look at that. So notice this function should return two things. So cipher text, comma, and tag. Do you see that? This will be very handy later on when we start to do things like digital signatures and things like that, right? So to be able to generate all this information together. All right, so we just have to call cipher underscore AES dot encrypt and digest. Okay. And this will take as input, of course, the data like that. So let's run this one. Okay, perfect. So it worked. All right, so now we are able to generate those two things. Let's print them out and just take a look at them. And then actually, we're going to start to think about how to write them to files, okay? Writing them to files so that we can, because you will need, this is the data that you're going to need to exchange. So let's do print ciphertext, ciphertext, and then we're also going to print tags. Okay. There we go. So you can see one is bigger than the other one. By basic, we have our parameters. So now you have a function that can give you these values fairly quickly. All right. Now what we want to do is, we don't want to exchange this, like copy pasting this. Instead, we're just going to save it to a file. So we know several ways of doing this, pickle or just, normal file. So in this case, I'll just use normal writing to a file. So file out. It's going to be equal to open. And then I'm just going to give it a name. So in this case, AES encrypted underscore encrypted dot bin. And just remember, you have to say write bytes, so WB. Okay. And now we can do file out dot write. And we're going to write cipher underscore text, basically. Remember to always close your file. So I'm just going to do file out dot close, just like that. So hopefully this will generate our file. All right, clear. And there it is, encrypted bin. So if we do cat encrypted. Oops, sorry. Oh, AES. AES. And, yeah. And there we have it. So now you have a file. This is what you would exchange, send to your classmate. Keep in mind, we are only sending ciphertext here, not the tag, right? So if I go to the, notice that what we wrote is cipher. Okay. Any questions on this example? Questions? All right, so let's do another one, another version of AES. And then, oh yeah, sorry. Oh yeah, sorry, yeah, of course. You get it? Still having issues? Okay. All right, so the next example, AES Encrypt 2, if you look in the GitHub, is just basically it's kind of like this one, just a little bit more things, uh, more detail basically. And we're going to use a different mode of operation, one that is more common to you, which should be CBC. Okay, but you can see how you can change these modes of operation. So let me just instead of rewriting the whole thing, I'm just going to copy it. So I'm going to do P A S and I'm going to call it AS encrypted 2. Oh, and I grabbed, sorry, it should be encrypt. .py. All right, so AES encrypt.py, and then I'm just going to do AES encrypt 2.py. Right? Does that look correct? All right, so I'm going to copy it. ls-l. So I have both now, encrypt and encrypt 2. So I'm just going to modify this file. There we go. All right. So I'm going to use this file. So let's see. I'm still going to use crypto cipher AES. From random, I'm still going to do get random bytes. Um, I'm still going to use this message. See what happens. Secret key is still from get random bytes. However, what I'm going to do now is I'm going to save that key, the secret key, into a file, right? And this is because remember, where AES is, to encrypt the message, but then we're also going to have to figure out a way to exchange that secret key. So it's more useful to just have it in a separate file that we can grab it from later on and encrypt it with RSA. So let's go ahead and do that. So basically here, I'm going to add 3 lines of code that will help me to save this secret key. So I'm going to do file key. So it's going to be open. And then I'm going to create a file, AES underscore key dot txt. So that's going to be the secret key. Remember, this is unencrypted. because it's bytes, so it's going to be WB. So write bytes. Okay. So now I'm going to do file underscore key dot write. And the thing that I'm going to write is the key. All right. And finally, I'm just going to close the file key dot close. Okay. All right. So that should save the file, the secret key. Then I would proceed to encrypt. So cipher AES, AES.new, secret key, AES mode. I'm going to change it to CBC, doing something else, right? So just like we've discussed before. Then I'm going to do cipher AES, cipher AES. But this time around, I'm going to use a different function, right? So instead of encrypt and digest, I'm going to use the function just encrypt. Now, what you know about, what do you guys remember about CBC, the CBC mode of operation? We needed the message broken into blocks. We needed the key. And what else did we need for that? The initialization vector, remember that? So we're going to have to deal with that, but this function actually will make it easier for us to do. So let's see how that would be handled. All right, so I'm going to go ahead and cipher AES dot encrypt the data. That generates ciphertext, so I'm going to remove this tag here. So that tag was the digest, the hash. This is a different idea. So I have cipher. I'm going to get rid of this one. And I'm just going to comment out these two for now. Or three. All right. Let's run this just to make sure that it runs. This is encrypt, AES encrypt 2. So I'm going to do Python 3. Oh, it doesn't. Oh, data must be padded to 16-byte boundary in CBC mode. Okay, so same thing. So we just have to print the size of this. So print, right? Len data. 34. Says something about 16, right? Data must be padded to 16-byte boundaries. So 16, 32. What's the next one? 16, 32. 40? Okay.
48 should be that X.
48. All right. 48. Let's try that. All right. So how do we do that? So what was it? 34, 48. What's that? 14?
Yeah.
Okay. So 14. I want to keep it simple. So I'm just gonna do 14 things in here. But obviously you can write better code than this. So 1, 2, 3, 4, 5, 6, 7, 8. Hold on. 2, 3, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So let's go ahead. Perfect. Worked. Okay. So I have well, no errors, I should say. So we have our object, ciphertext, but that object actually includes the IV. All right. So what we need to do, how does this work? Ciphertext. Right, I remember now. Okay, so no, that's actually ciphertext is just the message. So what I'm printing here is just the encrypted message. The object, AES object, has the IV though. It kind of like generated its own IV, right? kind of in the background, so we don't see it, but it was used. The problem is when we decrypt, we are going to need it. Does that make sense, guys? So we need to extract it from the object, but that's pretty straightforward in this case. So I'm going to now basically create a file. So I'm going to re-enable these three lines here, but we're going to modify them just a little bit. So notice here, I'm going to say AES encrypted bin. So I'm going to just overwrite the old AES encrypted bin. I'm still using WB because I'm writing bytes. But now I'm going to need to do two writes. And just keep in mind, just like when you took C, C++, just think of this as a buffer in memory, right? So, it's just a buffer in memory. We're going to write, and then we're going to continue to write. So the initialization vector, I'm guessing, is probably 16 bytes, right? And then the rest is the encrypted message. So we're going to do file out here, dot write. Do you see that? And then it's going to be, this is going to be the initialization vector. So that needs to come from Cypher AES, which is the object that needed that. And so it generated it automatically. So I'm going to say Cypher underscore AES dot IV. Does that make sense? And notice that's going to be just like appended to the message so that when you send this to your partner, they'll receive the IV and the message. They just need to know that they need to grab the first 16 bytes as the initialization vector and the rest as the message. So it's a nice solution to the problem, I think. Pretty elegant. All right, so now that we have this one, then we do write ciphertext as well, file close, and that's it. So there you go. You guys now can do very, in a secure way, confidentiality, right? You can use the AES module, can generate your random key, right? You're using CBC, which is a mode of operation you're familiar with, and you can send a message. Very likely on the practical exam, I'm telling you this right now, this will be one of the scripts that I use to hide the message, right? So I'm going to write something here. I always write a quote from a movie, and then the question is, what movie is this from? Something like that, or a TV show or something. I'll make it age appropriate for you guys. All right. So anyway, but yeah, so that's kind of what I do on the. So this is the thing that you will be looking for. Okay. You just have to like reverse engineer it. And you will need, as I said, this key, but I already showed you how to create a file from it, right? And so the reverse thing would be that from a file, you'll need to like get it or something. Or you may be able to just type it up. It's only 16 things. All right, so let's go ahead and run this one. So yeah, that should be it. Okay, no errors. There. ls-l. So everything should be here, right, in this bin. 64, I wasn't paying attention to the size of it before, so I don't know if any of you looked at it or remembers what this was before, but it is now 64. All right, so now obviously I've encrypted the message. You guys now need to, let's say this is we're attacking on Tuesday at 3 a.m. So, something important. So you would send this message, right? And that's the information, but you also need to send a key. So that will be another thing we need to discuss using the RSA modules. But for now, let's assume that we've already securely exchanged the key, right? Let's assume that. And so now we need to create the scripts for decrypting AES. The key is here, right? So we know that. So let's go ahead and do that. So I'm going to let's see. We're using this one. We generated this key, right? Okay, so now we need to decrypt this. So we need to get back. Today is Thursday, October 10th, 2024. That's our goal. So I'm going to create a new script. I'm going to call it AES decrypt 2. Okay. So hopefully this, should be easy. Um, AES decrypt, right? So decrypt. Right? So AES decrypt 2 dot py. All right. So the same thing as before from crypto dot cipher import AES. Right. So we obviously need to use the same algorithm. That's all the same structure, but this time around we need to get the key from a file. Right. So um, let's do that first. So I'm going to do file key. Open, open, and I think it was called AES key, right? So AES key dot txt. I would say. Yeah. So I'm trying to read this file because this has, those 16 bytes that we generated, which made up the secret key. Okay. Obviously, this assumes that we have exchanged the key somehow, but currently the key is available to everyone, so we haven't exchanged it securely. All right, so decrypt. So we have the key there. Um, oh, and we need to specify the how we're going to read it. So we need to do read RB. So we're going to read bytes, basically. Okay. All right. Once we have that, let's bring it into memory. So I'm going to do secret key file key, and this is missing an assignment statement. So file key dot read, and then file key dot close. All right, there we go. Everyone with me? Okay, perfect. So we've got the key in theory, right? Let's instantiate um the cipher object. So I'm going to do cipher AES should be AES dot new, which takes the secret key, but this also takes the mode of operation, AES dot mode CBC. Remember, it has to match, right? It has to be CBC. We've talked about that. Here, though, this also needs the initialization vector. Okay. as you guys remember from the algorithm that we implemented. So we need to have that. That's in the file that contains the ciphertext, the first 16 bytes. So we need to retrieve that. I think. All right, so we don't have that information yet. So then let's go ahead. Before we invoke this, let's read that file. So I'm going to say file in assignment statement, open, and the name of that file was aesencrypted.bin, aesencrypted.bin, and we're going to say read bytes, RB. So we're going to try to bring that in. So now we are going to read it in parts. So we know that the first 16 bytes are going to be the IV. So then we're going to say IV file in dot read. And all we have to do is do that. Does that make sense? Do you know why? No. So we created the key to be 16 and the initialization vector was also 16. So let's go back to here, right? AES encrypt 2. Secret key 16, generate random byte 16. Um, then cipher AES generated an initialization vector, and here's the key. When I wrote to AES encrypted, I did two writes. The first one was cipher AES.iv, those 16 bytes that make up the initialization vector, followed by the actual cipher of the message. Does that make sense, guys? The rest. Right? So now I've got everything in one place. Imagine it's like this almost, right? And so I'm grabbing these 16 bytes and then the rest of the message. Just think about that. All right. So let's go ahead and camera died. That's great. I don't know. I guess let me end this video and I'll start a new one. All right, so I'll start a new video.